All right, well, thanks for being here. It's a full room. I appreciate it. So we're going to be talking today about quality assurance and penetration testing. I'm sure it's a very popular topic among penetration testers. As one, I know it's really not a popular topic. And we'll talk about the reasons, basically, why I wanted to do this. Here's the outline. So nobody laughed. Are you guys all from IBM or what? I don't think you're allowed to laugh at IBM. I know you're not from Rapid7 because I don't have a contact high. So anyways, I work for Lockheed Martin. I've been there about 12 years. I took a break and did some consulting for a year and a half about in the middle of that. Like you heard, I'm also an adjunct professor at SMU. I've been teaching there for a while and teach mostly graduate courses in software security. I do some CISSP-like courses and things like that. So nowadays I spend a lot of my time doing training and education in security, which if you're in security, you probably do too, because the field is growing so fast that if you know anything about security, you're obligated to teach other people. Let's see. I'm here basically because I love my job. I love what I do. It's a great job when you tell people about what you do. They're usually one of the big comments I always get is, "Wow, that really sounds cool. You get to hack computers for a living." And I say, "Well, yeah, and some of my time, a lot of our time is spent doing other things, but yeah, I really do love my job." What other field can you tell people that you do penetration testing? Well, maybe there's a few others, but. Anyways, so yeah, I'm here because I want to make the field better. I feel like the field's growing so fast. There's so many people kind of coming into penetration testing. That's one of the, I would say, in my experience, it's one of the entry level jobs for security. Is you come in and you do security testing or penetration testing. And I've started to see some trends that are alarming. Maybe you've noticed some of the same things, but some things that I'm hoping we, as a community can kind of deal with before it becomes too much of, people already argue that some security is snake oil. We're selling things that don't work or trying to convince people of things that aren't real. And we don't want that to continue, and we don't want that to get worse. And with a lot of these trends that I'm seeing in new penetration testers or even pen testers that just haven't quite learned the craft or are just maybe getting lazy, or I don't know. There's several issues that we'll talk about, and I don't have all the answers for all the issues. I'm just trying to start the discussion and hope that people will kind of jump on board and realize that quality in penetration testing is an important thing. So that's really why I'm here. Oh, and I just wanted to say the views expressed in this presentation don't necessarily reflect the views of my employers, past or present, blah, blah, blah. If that really works. Do you think that really works? I didn't think so. I'd still get fired, right, if I said something. Maybe if Snowden would have known that and put that in his video. So let's see. Why are you here? So hopefully you're here. Maybe you are commissioning a pen test or an assessment, or you have in the past, or you will continue to do so in the future. And this talk is for you to help you kind of understand some things you should watch out for, some red flags, hopefully, some questions that you can ask when you're seeking penetration testing or talking to a consulting firm or something like that. Perhaps you're undergoing a security audit. This is becoming more and more prevalent in the industry, especially if you work in defense and banking, where you have third parties coming in, not to do an assessment to help you fix problems. They're coming in to do an audit. So they're coming in and doing penetration testing just to make sure that you are doing what you're supposed to be doing and looking for flaws. And we've had that happen several times over the last 2 years, and that's where this presentation actually came out of, is those security audit activities done by third parties, usually sponsored by some government organization wanting to come in and do an audit, or they like to call them CNAs. Who's ever been through a CNA or had to deal with CNA? So they're starting to add security audit, security penetration testing, those kinds of things to CNA activities. Typically it used to be they would come in and ask a bunch of questions, or they would look at paperwork or something like that. But we've actually had several teams of penetration testers come in to programs that I work with and work for, and do their own assessments, and then basically, hold the contractor, in my case, my company, responsible for those findings. So they develop a thing called a POAM. Anybody ever heard of a POAM? And it's basically, you can equate POAM with a finding, but it stands for Plan of Action and Mitigation, I think is the term. But really, when they say POAM, I mean, they treat it like a finding, a security finding. And you get so many days to work those off based on high, medium, low, those types of things. And if you don't, there are consequences to your program or your budget or something like that. So, like I said, a lot of this talk comes from these activities that I'm seeing where we are working with outside penetration testing teams that have been hired, usually third parties, some freelance consulting, things like that, smaller consulting firms that have come in and we've worked with. The other reason you might be here is because you're a pen tester and you enjoy getting roasted. I'm not gonna do any roasting. I'm just kidding. Maybe a little. Recent trends. So I already talked about number of security assessments increasing for various reasons, because security is hot right now. So I don't even need to talk about those, but some of the things I did want to mention is that we have seen in these audits and assessments as high as 25% false positive rates from some third-party assessments. That's a really, really high number. We don't expect, in most of the teams I've worked for, the consulting firms that I've worked for, you expect almost no false positives in a final report coming from a set of security consultants who have looked at it and reviewed it and things like that. If there is a false positive, maybe that you state that there's a chance in the report that this is a false positive based on these factors or whatever. But just blatant things that are just wrong, that's typically, you don't want to see that in a security assessment, especially, any quality. And the other thing that we see that's really alarming is that false positives and overranked findings are costing programs significant amounts of money. What do I mean by overranked findings? What I mean is, I couldn't think of a better word for that, but basically ranking priorities of findings in an inconsistent manner, or overranking them because the third-party assessor feels like they want this thing fixed, so they're not doing a risk assessment on your program. These guys came in and they were doing penetration tests. They don't know a lot about your system and the risk profile and threat factors and all of that. They basically know what they're seeing on this web application or this network scan, and they're making arbitrary decisions on finding ratings. Sometimes arbitrary, sometimes they're passed down to them by the customer, whether it be DoD or DHS or somebody like that that says, we rank these findings like this always without looking at risk factors at all. The problem with that is you end up spending money. We talk about risk analysis all the time. We talk about risk mitigation. It's all about spending as much money as it takes to mitigate the risk so that you're not overspending. You're not spending more on your risk mitigation than it would have cost you in the first place if the thing had been exploited. So it's an important factor in security, and it's one that is often missed in these security audits. And so an example of that I'll give is we've had a risk or a finding. We'll call it HTTP 500 error messages, right? So some people will call that information leakage. Anybody ever written up an information leakage on an HTTP 500? Depends on what's in it, right? Stack traces, things like that, come back and you get some information about the website that you probably shouldn't have, or the website probably shouldn't be giving out. But I've actually seen these findings written up in cases where there was just an HTTP 500, that's all. There was no extra information in it. It had the standard generic message, no stack trace, anything like that. And the customer was consistent, or this third-party assessor was consistently ranking these high. So that we're having to go spend money immediately because you've only got like 30 days or 60 days to go fix this thing. So you've got to go fix all these HTTP 500s. Is HTTP 500 necessarily a security risk? No, right? It's part of the HTTP spec for a reason. It's supposed to tell you that something bad happened, that an error message happened. If you've got something else watching for error messages and you're not getting HTTP 500s, then you don't know they're there. You can't deal with them. And literally the mitigation for this was, could y'all please just change these to HTTP 200 OKs and just put that same message that was on the 500, just put it in the 200. So you're changing the error code, but you're not changing the error message at all. And so we spent significant amounts of money fixing high finding. We couldn't talk them down either. We tried. I wrote white paper after white paper saying, explaining why this is not a security risk that we should be, you can put it informational, whatever you want, but this isn't something we should be dealing with on a high basis. This is us having to spend a lot of money, going to my developers or web admins or whoever and having them mitigate this thing that's really not worth the money. So it's important that we understand that as penetration testers, that the findings that we write up and the rankings that we write them up directly affect cost for whoever you're writing those up for. They've got to go spend money to fix this stuff. And if you're doing an irresponsible job of that, you're wasting their money, and it's not a good practice. And they will stop hiring you once they figure out, unless you're an auditor, and then you really can't. The government gets to decide. But another trend that we've seen is the people coming into penetration testing, I think, often misunderstand the craft or misunderstand the area. And I'm a professor, I'm a teacher, I love to teach. I have nothing against inviting people, into the community. I'm not an elitist. I teach for a reason because I love it. I love when students' eyes are open to the way penetration testing works or the way that security works, and the first time they ever use an HTTP proxy and they're like, oh my God, I didn't know you could even do this to a website. And that's cool for me to see that light bulb go on in their head. So that's not what this is about. What this is about is I interview people who say they are penetration testers, who have certifications, things like that. But they lack the technical foundation. You ask them if they've ever programmed before, and they're like, well, I've done a little scripting, or but I usually, have you ever done any professional programming before? Not that that's a technical requirement for being a penetration tester, but it certainly helps. They have to have some sort of technical foundation, programming, systems administration, networking. They have to understand the way things work in order to do penetration testing. It's an important piece of it. It does require a lot of knowledge. It requires a lot of technical knowledge and skill. And when you come in lacking those things, it just becomes really hard for you to understand how these things need to get fixed, writing up remediations, understanding other ways that you could cause the same thing to happen. The things that are important in a penetration test and doing a thorough, comprehensive job on a penetration test, they expect you to have this level of technical foundation. And in some of the interviews I've done recently, I've interviewed people that couldn't answer some simple questions. And these are real questions that I've asked people who claim to be penetration testers and they want a job on our team, or at least maybe a CISSP or something. And they couldn't get an answer. What's the difference between TCP and UDP? And I only ask these questions after they tell me something like, yeah, I do network penetration testing, or I've done network scanning before. And I'm like, hey, you've done scanning. Can you tell me the technical difference between these two protocols? And they're like, well, isn't one of them something about a connection? And they don't know the way it works. And so, yeah, that interview usually ends pretty quick. Somebody who tells me that they're a sysadmin or something, and I ask them, what the Linux host file does, and what are some of the security concerns with host files and things like that. And they're like, yeah, I think once I talked about that, it doesn't have something to do with internet addressing or DNS or something. So, and then somebody else will tell me they're software security, and they can't tell me the difference between the stack and the heap, which is none of these are really security questions. These are just technical, basic technical questions that we should be able to answer if we claim to be doing this type of work. So that's been alarming. Not to say that people can't pick this up and learn it. I'm just saying that when you call yourself a professional penetration tester, there's some basic skills that really should be there. It's a technical foundation that I feel is lacking in a lot of cases. So I wanted to go over some of the top mistakes that I've seen in the last two and a half years that I've been doing this thing where, my team kind of oversees audits a lot. So we oversee these government auditors or other auditors that come in and do security testing against these programs. And so we're there to kind of vet the findings. So they give them to us. The program doesn't know what these findings mean. They're not security people typically. So the findings and reports come to my team. My team analyzes them and says, okay, here's what we need to do to get all this stuff fixed. And what we found is that we were spending a lot of time having to weed out false positives with these penetration tests. And then some of the reasons for that would be a lack of understanding. We've seen very poor reporting coming out of some of these penetration tests. We've seen some tool blunders, of course, and quite a bit of miseducation about findings and about the underlying issues. And a lot of that has to do with just bad information that's out there. Some of it is just they didn't do their research or homework. But we'll talk about each of these areas, and hopefully I have examples of each of these, and maybe they'll resonate with some of you. Maybe you don't make these mistakes. I'll say first off, I've made some of these mistakes. And so I'm not saying that people don't make mistakes and that we shouldn't. I'm saying if we have a proper process and peer review and things like that, other people who are backing us up, we should have enough information, and we should put things in place that ensure quality in our penetration test. So I'm not saying that people shouldn't mess up and that penetration testers are perfect and should be geniuses and all of that. I'm really not trying to say that. What I'm trying to say is we need to up our game in quality when it comes to these types of tests. All right. And some of these you'll find, I mean, some of these are just blatantly unacceptable, you'll see. And these are real, all of these come from real findings from real assessments. So I didn't make any of these up. Some of them I had to recreate because I couldn't give the, IP addresses or domain names or whatever. But they're all from real reports and real penetration tests. So false positives. The reason we see a lot of false positives coming out of these assessments that I've been a part of, a lot of times has to do with incomplete test cases. So the tester has been taught a single way to do something, and that's the only way they know how to do it. Perhaps because of a skill gap, that they just don't know how the thing works. So somebody taught them to type in this when you're testing for cross-site script, or somebody said, why don't you go to, RSnake is here and talking tomorrow, I guess, so why don't you go to RSnake's cheat sheet and type in that, and if something bad happens or you see something weird, then maybe you have an indication of cross-site scripting, and that's all they know. They don't realize that there's a whole lot of other details that go along with finding cross-site scripting. Perhaps there's nothing on the next page. When the page reloads, there's no indication of cross-site scripting, but really the attack was stored somewhere, and you're going to see it later in the application. Scanners are not good at finding those. Sometimes they find them, sometimes they don't. But humans can usually realize, okay, I just put this in this whatever name field, this gets stored over here, and then later they're going to echo this name field back to this page, and I need to go check that. It's not all that difficult, but if you've never been kind of walked through these things, and you're just pushing scan on a scanner, that's, by the way, I didn't introduce my friend here. His name is Scan Monkey, and we came up with Scan Monkey as a part of this whole thing a while back. So sometimes when we see penetration testers that really don't know what they're doing and they are just hitting scan, that was our affectionate name for that type of penetration tester. So I apologize, it is kind of offensive. But anyway, so Scan Monkey's my new friend. So anyways, people who just push scan and then they don't do any analysis on the findings, I've seen that quite a bit. Everybody, I think in here would agree that that is not acceptable to hit scan on a scanner and then go turn in that report as your penetration test. If you're doing that, I would really highly encourage you to stop doing that. So scanners are often wrong. There's lots of things they miss. Scanners have lots of weaknesses. They're getting better. I use scanners in certain instances. We do what we like to call focus scanning rather than just turning the thing loose on a website. Everybody knows what happens when you turn IBM or HP's product loose on a website. Even if it's in a test environment, you just hope that you've backed it up before you hit scan. So the other thing is improper test procedures. I have an example of that next, so I won't go too far into that, but this is basically, we don't really understand this finding, but we kind of know that if you do this, sometimes bad things happen or whatever. They just don't have consistent way to test something. They've never really researched what the finding is. They see it in a scanner and they're like, oh yeah, that's probably true, and they just put it into the report. Oh, and don't forget about false negatives. Thank you, Scan Monkey. Yeah, so that's the other big thing is there's one thing to see findings in a report and then go through that and say, this is not right, I know this is not right, I can validate this and go retest this, but what about the stuff that wasn't seen? What about all the stuff they missed because of these same types of mistakes? So that's one that it's hard to judge, how many false negatives were there in these assessments. But it's also something that kind of worries me because there could be a whole bunch of stuff that's been missed for these same reasons. If you've got this many false positives, you've got a problem with false negatives. So in this example, this is one of my favorite examples. I actually love to tell this story because it was a win for me. We had this oppressive third-party audit team come in, and they were trying to destroy all of our websites. We had tested these websites before, so my team also does what we call pre-audits. And so if you know you're getting audited, you can call us in, and we will do a pre-audit for you and help you clean up stuff and fix stuff. It's a necessary evil, I guess, when you know you're going to be audited. You don't want to look bad to the customer. And so we did a pre-audit, and we had tested this site extensively. This is just an example again, but this is based on a real finding. And so I was pretty sure that we had caught all of these types of problems, cross-site request forgery. And we had thoroughly tested it. We had them fix some CSRF problems, and they had done a pretty good job of it. So when this finding came up in the actual audit, I was really surprised. And my heart kind of sank for a minute because you don't like to be the team that came in first and then somebody else found something that you didn't find, right? And that happens, and I always equate penetration testing to kind of like home inspection, where if you hire 2 home inspectors, you're not going to get the same set of findings. Pen testing is very, very similar. If you hire 2 different pen testers, you're probably not going to get the same set of findings. So that does happen, but you don't like to be the one that missed something. So I inspected this a little bit closer. I don't think anybody can read that from there. So I'll blow it up a little bit. Inspected the URL a little bit closer, and what did I see in there? Oh, that looks to me like a CSRF token. Okay, so they wrote up CSRF, but in the screenshot and example they gave, they actually put the CSRF token in the attack. So I ran this attack again and again, and I realized, wait, this doesn't work. You can remove the token, and it does. You don't get cross-site request forgery. You don't. The request doesn't go through. You can modify the token, and it catches it, validates the token, and the request doesn't go through. So it's like, how in the world is this CSRF? And so we called them up, and actually what I did first, because I was a little bit peeved, I made a really humiliating video that was like step-by-step how to test for CSRF. I really did this. I made a video, and I sent it to the testers, and I was like, just so that they understand the way that CSRF works. And it was like, if you put the token in the attack, of course the attack is going to work. The token is supposed to be the unknown piece that you don't have. So anyways, they said, well, no, I know this happened. There was something about if we completely remove it, or wait, let me go retest. I'll be back in 10 minutes, they told me. I was actually on the phone, but I'll call you back in 10 minutes. And I waited 10 minutes, 15 minutes went by. I got an email that said, still testing. About an hour and a half later, we finally got the phone call, and they were like, yeah, we can't repeat this finding. And I was like, yeah, I pretty much knew. I could see their screenshot. I knew exactly what they had done. And so anyways, it was a case where just a really blatant false positive, improper testing procedures. They didn't understand. I think they thought they might have been looking for the CSRF token down in the payload and not up in the URL, something like that. Should the token be in the URL? Probably not. But they were typing this in manually, so they were passing the token via the URL. So I don't think the website was actually generating that URL. I think it was the tester doing that. But anyways, it was a win for me, and I was excited when they had to admit they were wrong. All right, so another thing about false positives or these types of issues is a lack of understanding. Learning a testing technique without understanding the vulnerability. So I can teach penetration testing. I say this all the time. I can teach penetration testing to almost anyone who knows how to use a computer. I can tell you to go to Arsenic's site and copy those XSS cheat sheet things. I can tell you to type tick or 1 = 1 in a browser and see if something bad happens and say that that's how you test for SQL injection. But that's not really, that's not responsible. That's not the way I should be teaching security. It's not the way I should be teaching penetration testing either. I can teach you how to turn on a tool and type in the correct URL and get it to spider and then get it to scan and all that stuff. I can teach all of those things very, very easily. That does not mean that you know what you're doing when you do a penetration test. So I find that a lot of testers, they give us findings that show a blatant lack of understanding for the limitations of the scanner. So they just don't understand that the scanner is not good at finding these types of things. I have another CSRF example, I think later in the presentation, that comes from a scanner, and you'll see why scanners are not great at testing CSRF. They're getting better, but this one that we were using was, and it even tells you, you need to do some analysis. You need to go inspect this and see if it's true. And the other thing is just not understanding the underlying technology. How many testers, and sometimes we have to do this, actually often we have to do this, right? Where we're testing a technology that we've never seen before. I mean, anybody else been there? All right, so I've done it, like SAP. They asked me to do an SAP test, and I was like, I've never once seen SAP. So what did I do? I went and did some homework. I watched a couple classes by that guy that teaches at Black Hat, forgot his name. Anyways, one of the foremost experts on SAP security. I went and pulled up anything I could find on the internet from that guy, watched some presentations, read up on it, read up on just SAP. How does SAP work? What is it used for? What are the technologies involved? And once you've done enough different types of technologies, you start to equate things. Okay, I've seen something like this before. I've worked with IBM products, or I've worked with these other kinds of systems that are similar, and you start to understand. Do you understand it really deeply? No. Sometimes you have to do a test on things that you don't quite understand as well as you would like. So I'm not dissing that. That's just the way it turns out sometimes. But I find that a lot of times they're doing, in the middle of a test, they have no idea what they're doing. And like web services or something like that. I had some testers testing web services. This is what this example is about. They were testing a web service. I think this was SOAP. And they kept telling me the password's not working. And I already tested this website, and I knew it was in pretty good shape, or this web service anyway. So they were like, the password's not working. Well, first they asked me, how do I make requests? That was my first indication. How do I make requests to this web service? And I was like, well, did you look at the WSDL? Well, what's a WSDL? Okay, so I had him go to the WSDL, and I'm like, okay, this is the XML that defines this web service. You need to create a request that looks like this. Do you have an example? Oh, that's the shortcut. Do you have an example? They always ask for an example because they just want to see the example so they can mess with it a little bit. I'm like, no, unfortunately, we don't have any example requests. You're just going to have to generate a request on your own. Like the website pretty much tells you when you do it wrong too. So you try to put all the different parameters in there, and if one is wrong, it usually, a lot of times, will come back and tell you this parameter is not correct. Anyways, it was telling him the password was not correct, and he didn't understand what was going on. And I said, well, I already knew what was going on, and I was kind of being a little cheeky, but I was like, well, are you sure that all those characters are valid for SOAP request? And he's like, oh, I don't know. And so I said, well, what about that first character, that ampersand? That's part of the password, but you might need to encode that character. And he was like, okay, encoding characters. And he goes, where's my next slide? Oh yeah, he goes like that. Puts %26 to blah, 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 blah. So he did some encoding, he replaced it, and I was like, yeah, you're gonna need a different type of encoding. That's not gonna work in this SOAP message. And so he was like, okay, I got it. And he puts a \38 in there. And I said, try again. And I was like, what you need to do, I just told him I was like, you need to do HTTP encoding. And he goes, HTTP encoding, okay. And he doesn't get it, and he starts to Google it, and then I'm like, okay, literally type these characters, ampersand, AMP, semicolon. But what that told me is the guy really had never done a test on a website, on a web service before. He had never issued SOAP requests like this. He had me draw on the board how web services work and how this specific web service worked. And he's the guy responsible for finding flaws in this thing, but he doesn't even understand the basics of how it works. So that's just an example. Poor reporting. I think everybody can relate to this. Reporting is hard, and reporting is not fun, typically. Some people like it, but I don't. I struggle with reporting as well. But there's some big mistakes that we should not make. And I've already mentioned copy and pasting from scanner output. Just shouldn't be doing it. Going in and out.
Try the handheld. Right here, yeah.
Right.
You can just turn that one off.
All right. 1, 2. All right. Poor organization of findings. That we find that all the time. So we got handed from some of the assessors I'm talking about. This happens often with these audits and assessments that they come in. A lot of times they're not responsible for even producing like any quality report at all. Their responsibility is to generate these poems or generate these findings and go put them in their back-end system so that they can track them. But the way they give them to you, we've gotten straight out just scans. App scan or web inspect, just straight out, here's what the scanner told us, go fix all this stuff. We've gotten spreadsheets, Excel spreadsheets that just have some columns in them, no reproduction steps. Half the time we don't know exactly where the finding was in the website because we were given just a part of a URL or maybe the main URL, and it's telling us to go look for cross-site scripting. Then they'll say, oh, no, but we have an associated Word document that we put some screenshots in. Good luck finding that Word document because who knows what it's named. Sometimes they would put the correct name in there. They would hand us folders full of stuff, just Excel spreadsheets and screenshots and scans and stuff. So it was almost impossible. We had to go through and reanalyze and reorganize all of the findings. And customers should not have to do that. It should be obvious. It should be very clear. I think everything should be in a single package or bundle. And if you do include, it's okay to include scan reports, but as like appendices or something like that, as supplementary. They shouldn't really have to go, if they need some really low-level detail of what's going on, maybe they go to the scan for that. But really what they need should be in your main report. No reproduction steps is a huge one, or wrong reproduction steps, or reproduction steps that are very specific to the way they did it and not, if you go back in and do it, there's a whole bunch of variation of, oh, well, you had to do all of this first before you could do this part of the reproduction, and none of that was in there. So a lot of times my team would have to go reanalyze these findings, refigure out exactly how they exploited them, spend all of that much time trying to figure out what this tester did to get to this finding. Missing or poor screenshots. We found so many times where they took the wrong screenshot, right? I don't know if anybody else has. I've done that before, but we usually catch it in the review. But just completely wrong screenshot with some finding. In this case, so this was a report. The finding title in the report was Insecure DB Update Log Injection. Okay, that's really, I don't really even know what that is by reading it. Insecure DB Update Log Injection. I know what log injection is. Insecure DB update, maybe. But when I actually read this finding, the actual finding was improper access control. This is a website that was not doing proper access control. That's all it was. So you could issue some request and the website would honor the request, but it shouldn't because you don't have access to that, or you're not authorized to do that thing. So the title didn't even match the actual finding. And then here's what the remediation said. Ensure that a user does in fact have access rights to change a database row before allowing the user to change it. We're talking a web application here. So I'm not sure what they're talking about access rights to change databases. So when I went and talked to this guy, he actually didn't even understand the way that a website interacts with a database typically. So a typical architecture is that the website logs into the database, right, with its own account, and the web application has pretty much full rights on the data in the database. And that application acts on behalf of a user. And so users don't have database accounts, and you don't typically check to see if they have access to things, to rows and columns and stuff like that in the database. So he was suggesting you do some sort of database access control when this thing was really a web application, and what he should have been doing is web application access control or role-based authentication or something. But his remediation, I mean, this was just a crazy finding that made absolutely no sense. And I don't think we ever use this guy again for a penetration test. Another finding that I found recently is cross-site scripting injection. Has anybody ever seen a finding called this, cross-site scripting injection? Because I scraped the internet. I kept asking all my friends, does anybody know what cross-site scripting injection is? Nobody did. If nobody knows what that finding is, and if it's not some, if you can't go to the CWE or somewhere and find the name of your finding in there, it might not be a real finding. So they were calling this thing cross-site scripting injection, and they really did put the injection on for a reason. It wasn't just because they didn't know the name of cross-site scripting or the name of that finding. It's because they were trying to say it was something a little bit different than cross-site scripting. because they knew that. And so in the finding itself, it said admins and web designers can use this to inject scripts onto a page. And I was like, okay, what are we testing here? And then I go further read down in their report, and they wrote this. I didn't write this. The page is intended to let designers edit HTML pages and scripts. Then I'm like, okay, I look at the product, and this is a finding against SharePoint. SharePoint Designer. And lo and behold, if you were an admin or a web designer in SharePoint, you can inject scripts onto a page. So we had to go back and say, yeah, I think that's kind of the intent of this feature. And not sure that this was a real finding. All right, moving on to tool blenders. We've got to move fast because I need to get past this to some of the other stuff. Anyways, tool blenders, attack of the scan monkeys, people hitting scan and they don't know what the scanner does, and they're tearing up your websites, tearing up your databases, we've actually done this before, and I hate to admit it, but we were scanning a website, and in the comment field, we scanned the comment field, and the comment field sends real emails to real people when you do that. And so we had all kinds of calls to the help desk saying, I'm getting weird emails that have things like bracket script, bracket alert, blah, blah, blah in them. And so that was not good. You have to figure out what parts you should be scanning. Even in a test environment, this thing was sending real emails. So anyways, it's happened. No tool vetting process. We've had all kinds of crashes and things like that happen on systems where they brought up some tool like some old version of FG dump or PW dump or something like that, and all of a sudden LSAS crashes. And you know what happens when LSAS crashes on a Windows machine? You get BSOD. So, and this is on a production server sometimes and stuff like that. So it's because some guy just picked up a tool that he's like, how do you do pass the hash again? Or what was the tool for that? And they just go Google it and they go download whatever the first tool they see. And they run that tool, and then that tool crashes. So it's important that we have tool vetting processes and that we're not using arbitrary tools. Do we need to be creative and we need to be adaptive and all that stuff? Yes. But at the same time, we can't just go pulling tools off the internet and just running them because, or even, I think ScanMonkey has something to say about this, but it came with Backtrack. I've heard that one before. It should be okay to use, right? So anyways, relying on scanners only, obviously. No analysis of the scan findings. We've already talked about that. I'm going to move a little bit quicker. Here's one that I talked about with CSRF. Scanners are not great at finding CSRF. Here's what the scanner said. The test result seems to indicate a vulnerability because the same request was sent twice in different sessions and the same response was received. Okay, that's how the scanner thinks it's CSRF. When you look at the response, this is what you get. You have encountered an invalid username, or you've either entered an invalid username or password, or your account has been locked. The scanner had locked itself out, and so it was calling everything CSRF because everything was returning the same request, or the same response. Another example, I was going to let you guys analyze this for a second, but since we're a little short on time, I'll just tell you what's about to happen. This guy was manually testing in Burp, and he had done some cross-site scripting that was actually successful up in the request. And then he clicked on that request, right-clicked on that same request, and did do an active scan. If you do an active scan with a request that already has cross-site scripting attacks in it, you're going to get something like this. And that's exactly what happened. I just thought that one was funny. That was actually somebody from my team. Relying on scanners. I tested a product that they told me had been tested 12 times. This was actually a pretty good product from overseas, Australian written software. It actually was really, looked to be a really good piece of software. And I'd been tested a bunch. It was Cold Fusion. And literally within about an hour or two, I found that they had absolutely no access control on the website. So they were using the Mach 2 framework in Cold Fusion, but they were not using the access control piece of that framework. And so if you knew any of the URLs, any of the admin URLs, you could change everybody's passwords, change any of the settings. And these guys had 12 penetration tests. They showed me from government organizations and stuff like that. So that was really alarming. And they did not believe that this was a real finding, because how could they have 12 penetration tests and nobody found that they had absolutely no access control in this application? It was because they were using a scanner, and scanners are not good at doing access control violation or access control testing. They can do it, but they're not great at it. Miseducation, I wanted to harp on, since we're here, OWASP just a little bit. So I'm just gonna go straight to this one. Has anybody played with iGoat before? My time's running out. anyways, if you've ever played with iGo, there's some bad suggested solutions in there. This one's got a hard-coded, or it's passing the username and password on the URL. That's their suggested solution. This one, they're passing a secret key to a database in the code itself, and that's the suggested solution. So, sorry, OWASP, we can do better than that. Quality assurance, what can we learn from QA? I'm gonna have to buzz through this, but it's not about taking the creativity out of penetration testing. First time somebody ever told me we needed QA, and they were like, you know, you guys have to be subject to QA. We have to review your reports and stuff. I got mad about that or whatever, but I realize now, folly of my ways. Quality reduces cost in all cases to the testers and to the customer. It's something that we need to concentrate on. When I looked up quality assurance, just straight from Wikipedia, here's two things I found. Fit for purpose and right the first time. And we really need to think about that. Does penetration testing fit this purpose? Are we doing the right thing? Or should we be doing something else? Architecture assessment, code review, something else. We have to know what penetration is good at and what it's not good at finding. And are we doing it right the first time? I thought those were good lessons. Zero knowledge, if you're doing a lot of zero knowledge, I would really think twice about that. This is a paid gig, not a CTF competition. The goal is to find flaws, not to prove how elite you are. Black box tests are, I'm not saying don't do black box tests ever, but they serve a different purpose than most of what most customers want from a penetration test. They want you to find flaws. They want to know what's wrong with their systems. Sometimes they want you to test their security mechanisms and the response, and you should do that. But that's a different type of penetration test, and you need to know which one they want and which one you need to be doing. So collaborative, I think, is the way to go in most cases. Security testing, I'm going to actually breeze through this slide. It's not that important. Pen testing is QA, so I used to argue that. Pen testing is QA, so do we really have to do QA on pen testing? Well, we do. We're selling it as a product, and we're using it to sell products, so it's subject to quality. But it's a black art, right? I mean, it's artistic. We can't put QA on an art. But yeah, the same way that we know the difference between quality art and poor quality art, we know the difference between a poor penetration test and a good one. Again, I apologize for going so fast. Our team started doing these things actually. So ISO 9001 procedures, controlling your documents, controlling your records and procedures. Doing internal audits on your process for doing penetration testing, on your pen testing mechanisms and processes. Dealing with nonconformance, the how, and then dealing with the corrective action, the what. So how is it wrong, and what are we going to do to fix it, and preventative actions. So we've actually instilled these now in our process and are trying to better our team and better ourselves. By using just standard quality assurance techniques. Can tools help? I think they can. So there's tools out there that some people use that are not really fit for the purpose as much, collaboration tools maybe, SharePoint, things like that. But we have actually found a few tools. ThreadFix is one. Is anybody from Denim in here? No. Anyways, Denim has a tool. Their tool is specifically for web application findings, mostly from like scanner type stuff. But one of the best parts of tools, these types of tools, is automated report generation. If you can document your findings as you go and then hit a button and it spits out a really pretty, really consistent, comprehensive, detailed report, that's awesome. Then not everybody has to be word wizards. We actually wrote our own tool to do this. We call it RTS. We're actually writing a new version now called SAMS. And you basically define assessments and metadata along with those assessments. And then you define the test cases, the targets, and we have a bank of findings that we use. You can always create new findings if there's something specific. You can add screenshots, you can add custom notes. You put all of this in the tool. You can see who's currently testing, what phase they're in, how much they've tested, what percentage of completion they are on this penetration test. All of that kind of stuff. Associate findings with targets. So this finding came from this target, that kind of stuff. It's an awesome system that we've been using for years, and it really, really helps us to keep track of what's going on and to get a better quality pen test in the end. And the thing that I wanted to kind of mention is I'm working with OWASP now to develop a project similar that we can share with the community. So we can't give you the code, unfortunately, for the one that we built, but we can donate, you know, our brains and some of the design features and things like that. So I'm working with OWASP now to build a project to build a security assessment tool like this, so that people can hopefully have, instead of just some new tool that does hacking or that some kind of new exploit tool or whatever, this is a tool basically to help us with workflow and help us do a better quality job. So that's what I'm working on. This is my goal for this next year. So, sorry I went a little long.
All right, give it up for Aaron.